Let's see how the compound magnesium chloride is formed. Formation of magnesium chloride. It is an ionic compound, or it is also known as they are also known as electrovalent compound. So in order to study this, let's see what is the atomic number of magnesium. The atomic number of magnesium is 12. Write magnesium as this, and chlorine is 17. So the atomic number of magnesium is 12, which means that in the magnesium atom, in the nucleus there are 12 protons, and around it 12 electrons are revolving. An electronic configuration of an element means how the electrons are arranged around the nucleus in the shells, in the various shells. The first shell is called K shell, then L, then M, then N shells. So the configuration is 282. It means there are 2 electrons in the first shell, K shell, then 8 electrons in the L shell, and 2 electrons in the N shell. So N shell for magnesium atom is the outermost shell, which is also called valence shell. So they are called also known as valence electron. The electrons that are present in the outermost shell of an electron uh, are known as valence electrons because they are present in the valence shell. But they are very important because they are the one, these electrons are the one which determine the chemical property of an element. How magnesium element will behave depends on its atomic structure, the electronic configuration, and that too precisely depends on the number of electrons that are present in the outermost shell of an electron. So configuration is very important. The electronic configuration in determining in telling or predicting the chemical property of an element, and and within that, the outermost shell, the valence electrons, are the one which will tell how they will behave. So this is the configuration of magnesium. So what happens is magnesium, how will it become stable? It will stable by according to octet rule, it will become stable by having 8 electrons in the outermost shell, because having 8 electrons in the outermost shell, because all the inert gases we know they are very stable, they do not react with any other element, and we found that they have 8 electrons in their outermost shell, which are called inert gases, or the gases that are present on in group number 18 of the modern periodic table, the helium, neon, argon. Those gases are called inert gases. So there was a rule made called octet rule, which says that uh, an atom will react in such a way or combine with any other atom in such a way to become octet. So that the electronic configuration becomes octet. So octet is an electronic configuration which is stable and having 8 electrons in the outermost shell. So magnesium will become stable only when it has 8 electrons in the outermost shell. How will it have? Either it can take 6 electrons, or it can give away 2 electrons. So nature, what does nature follow? Nature always follows the things, or it does the things where there is less expense of energy, where it takes less energy. So instead of taking 6 electrons, it's better you give away 2 electrons. So the 2 electrons will be given away. 2 electrons are given away. So a configuration becomes 2,8. And what about charge? It will become a positively charged species. We call it cation. So it becomes magnesium cation carrying two positive charges. Why? Here the number of electrons and number of protons were same. One proton and one electron, they carry, although they different mass, they carry same amount of charge. One carries positive charge, one carries negative charge. Because in an atom, the number of protons and electrons are same. The charges, they cancel each other. The charge becomes neutral. But when it gives away 2 electrons, it becomes positively charged species, because the number of protons are more now here. Still, it is having 12 protons, but only 10 electrons. So because of the 12 protons, it is carrying two positive charges, because protons carry positive charge, right? So it becomes magnesium cation. This is more stable. Magnesium ion. containing two positive charges is more stable than magnesium atom. Similarly, what about chlorine? Chlorine has atomic number 17, so the configuration is 287. So in order, so according to octet rule, in order to become stable, in order to, it's better to get transfer one electrons in the outermost shell instead of giving 7 electrons away. So it will take one electron. And now when taking one electron, when one electron is transferred to its outermost shell, the configuration becomes 287 to 288, which is again octet, the 8 electrons in the outermost shell according to octet rule. And this is the electronic configuration of argon gas. Just so it is stable, as stable as argon, and this one is as stable as the neon gas. This is the electronic configuration of neon gas, and this is the electronic configuration of argon gas. Those are stable gases. So chloride ion, which is chloride anion, is more stable than chlorine. Magnesium ion is more stable than magnesium. So these two are special, more stable species than these two. So let's come to the topic, how magnesium chloride is formed. So now, in order to understand this, we are going to depict the number of electrons, the valence electrons, using dots and cross. So we are writing magnesium. We are writing only the yeah, we are not writing all the electrons. We will just write depict only two outermost electrons, the valence electron, two crosses. And for chlorine atom, there are 7 electrons in the outermost shell. So 1, 2, 3, 4, 5, 6, 7. We are representing it with seven dots. So magnesium atom will give away one electron, but chlorine is able to take only one electron. So one electron will transfer from magnesium to chlorine, right? And what about another? But it has one more electron to be transferred. So it will need one more chlorine atom to come near it, and it will transfer the electron to it. So 2 electrons are transferred, one to each chlorine atom. So how will you write this? Magnesium will become magnesium ion like this, magnesium 2 plus, magnesium cation, positive charge species. And what about chlorine? Chlorine atom, it has 7 electrons represented by dots. Sorry, 6. Okay, 6 electrons represented by dots, and one cross electron, one electron represented by cross transferred from magnesium. Right, I'm writing this one here. So the cross here, it has been transferred from the magnesium atom, right? But we have two species, so instead of writing it 2 times, we just write it once and we put 2. Since it will carry a negative charge, and negative charge is kept here, and this kind of species, let's keep it inside. There will be 2 chloride ions, so I'm writing 2 over here. So this is how magnesium chloride, MgCl2, is formed, and they are called ionic compounds or electrovalent compounds because because they are formed by transfer of electrons, the valence electrons from one species to another, which is actually from a metal to non-metal. Magnesium is a metal, and chlorine is a non-metal. So electrovalent compounds are those compounds which are formed by transfer of electrons from a metal to non-metal. So an electrovalent compound or an ionic compound will always contain a metal and a non-metal. Whenever you see a compound and you find that one is metal and another is non-metal, that means that is an electrovalent compound or an ionic compound. Ionic, why? Because they are made up of ions, magnesium ions and chloride ions, cations and anions attracting one another. The opposite charges attract each other, that we call electrostatic forces. So through electrostatic forces, these cations and anions, they get attracted to one another, and they stay closely to each other, forming the compound. So this is how magnesium chloride compound, the electrovalent or ionic compound, is formed through transfer of electrons from metals to non-metals.